All right. So, hello everyone. Welcome to lecture two of Intro to Backend Development. So now we're going to be talking about databases, but since it's been like 2 weeks since we've talked about routes, we're going to go over a short summary after the announcements. So, announcement on assignments. The demos are very useful for the assignments, as you've probably seen so far. So take advantage of them and rewatch them so that you guys know how to write up the routes in the future. And also, if you guys haven't seen on Ed, I've uploaded the test case file and I've actually updated it because there's a bug in it. So if you guys are doing like extra credit tier two, make sure you got the updated version. And also, you are required to upload like a collections file from Postman. So it's going to be a file of all of your endpoints that you do by creating a new collection and saving endpoints to it. And you can export it to JSON. If you guys want to see how it's done, we have a video um, on the textbook website under, I think it's the assignment requirements for routes. And also make sure the right documentation under every function and follow the API specification exactly. So like if you have the API, if you see the URL in the specification, it usually ends in a slash. If yours doesn't end in a slash, it'll typically not work in the test case and stuff like that. So make sure you have the same outputs, same inputs, and same exact URL formatting. And also one last thing, when you guys submit your assignments, there'll be a weekly feedback form on the textbook. So make sure to fill that out. It's always going to be there for every assignment. And it just talks about what you guys thought about the lecture and the demo and the assignment. And so you can improve on in the future. So yeah, that's also worth 5% of your grade. So now to go on to a review. 2 weeks ago, we talked about the client server model. So clients, if you guys remember, are like the things people use. So computers, mobile phones, video game consoles, stuff like that. And servers are also computers, but they're the things that serve the client's content and data. So they're often some company server house or server farm somewhere. And so clients send requests to the servers for content, and servers reply with responses that can typically have content or just status codes and so on. So clients ask and servers serve. So yeah. So requests, like I just said, are initiated by the client. They're sent to a specific URL, as you guys have seen in homework one. So like google.com/search is the search endpoint for Google. And the URL contains the domain, which is google.com, the path, which is /search, and then it can have optional URL parameters that you can just put in the URL for like variables. And you can also indicate the method that you want to use. So like get or post or delete and so on. And you can send meaningful data in the body of a request of either like a post request, delete request. And we use JSON here, so it's just key value pairs in brackets. So it's just like the same format as a Python dictionary. You use JSON dumps to get that. And so responses get triggered from the server or getting a request from a client, and it returns a confirmation of the requested operation, as well as the response code to determine what happened to that request, if it was successful, if it was not allowed, if it wasn't found, so on. And it can also send data back to the client via JSON. So here we have our client laptop and our server as a server computer thing. Clients send the requests. The server will check the route to run the code for handling that request. It'll do data operations, so it depends on what it's doing. Like it might be creating a new task, might be updating a task, so on. And then it'll return a response that goes back to the client. And yeah, that's kind of what we talked about in our first week. And now we're going to be talking about how to actually make an actual server without using like a Python dictionary. So one issue with Python dictionaries is that As you can see here, it does work for storing data. We can store posts with a key and also have values like the ID, the upvotes, the links, so on. But some issues is that when you restart your server, the data is lost, which isn't very good in case your server crashes or something. You don't want to lose all your data. And also, it doesn't scale efficiently since it's mainly used for Python dictionaries aren't really used for large amounts of data. And also, there's no enforcement on what kind of data goes into your dictionary. So you guys make a mistake where you accidentally put in, say like an int into your string field, and that kind of ruins your code. So the way we would solve that is by using an actual database. So what is a database? Definition of a database is that it's like a collection of organized information. You can easily access, update, and manage data you store in one. And you can also, they're also implemented as a collection of tables. So to reiterate, so here's an example of a table that would be in a database. So we would have like in our tasks table or post table, the ID of the entries and so on. So in this table, we have columns that represent the descriptive name and a specific data type. So IDs is the name of the first column. It holds integers. Name is the second column. It holds strings and so on. And the rows contain a set of values that represents one item. So like you see in the top row, it represents the person with ID 1. His name is Gonzalo. He's 22 years old and his hobby is gaming. And each row is a different person in this case. One thing that's required is that every row in this table has a unique identifier, so an ID. In databases, they typically automatically increment. So if you add a new person into this table, they'll automatically get the ID of 4 when they're created. And say you delete someone from like, you delete the first ID in this database. When you create a new person into the table, it won't reuse the ID you deleted. It'll just keep going from the biggest one. So it's not gonna reuse anything, which is pretty good for having to not have to deal with, okay, I have to go back and check if I use any IDs. That doesn't happen here. And one thing to really remember is that a database is not a table. It's actually a bunch of tables together. So a database stores a lot of tables. So it can store at least more than one. So we could have a users table and also have a posts table. We could have like table of transactions. We're gonna have only one. And yeah, just a collection of tables. And yeah, let me see what's next. Each table has their own ID column that's not necessarily related to the other table's ID column. And if you want to see how it looks compared to like the Python dictionary or JSON that you use for assignment 1, it'll look kind of like this. So the first row for Gonzalo would be like, it'd be in a user's list where the ID would be 1, name, Gonzalo, and a bunch of dictionaries in a list where you could just store it as a table. So yeah, do you guys have any questions about databases so far? Yeah.
So you said you can't do it on Python because it doesn't scale efficiently. Why is this just an issue?
I guess so, because like dictionaries in Python, they aren't very optimized for storing large. I mean, they can, but databases are specifically optimized for storing lots of data. Python dictionaries, they can store a lot as well. Like there's Redis, it's like some similar to Python dictionary, but it's mainly best used for smaller applications. Yeah. Yeah. Do you have a question up there?
Yeah, can you go back to the page?
Yeah, let me see where that is. Yeah. Yeah. All right. I'm gonna also, guys, reminder that we're gonna record all these lectures and I've already uploaded the slides onto the textbook. So if you guys want to look at any slides later or you want to look at them now, you can just go to lecture 2 and it should be up there. We hope we try to upload them pretty quick too. So continuing on, some benefits of databases are that one, the data is structured. So every column in a database will come with a type. So integer, string, these strings can have specific lengths of data. It can be Boolean, so on. It also scales well due to specific optimizations that are implemented in these databases. And also databases allow you to query data. So you can ask these databases like questions, and they're very helpful for finding data in large data sets. And they're a lot more flexible in doing that versus using a Python dictionary. And we'll show you that soon. So here's an example of how you would find, say, the people in a database of users who are over the age of 18. If you were doing this in homework 1, you would have to load the JSON of the users, kind of like in your Python database, it'd be a JSON format. You would have a list of over 18 users, and you have to loop through all the users in your Python dictionary that you loaded and checks for that individual if they're over 18 and then add them to the list. It's a lot of lines of code for something that should be pretty simple, but with databases, you can actually do it in one line. So you can select all the users from the users table where their age is over 18. So that was, oh yeah, what's up?
That one, does that one line lead to the database, or is it more parallel search to the database?
So it looks through the table users. What do you mean by parallel search?
It's like if this line moves through the database as well, then what's the difference between this and running a folder on the database?
So typically there are optimizations in using this method that because databases are they're created specifically for querying, searching, updating data in its tables. While Python, it's more of a general language. Like like compilers will optimize code. People optimize this structured query language to be fast for these operations. Sorry. Does anyone else have any questions before we go into structured query language? All right, so that was an example of structured query language. It's a mouthful, so we kind of just call it SQL or SQL. I don't know what you're supposed to call it. I usually call it SQL. I used to call it SQL, it was also long. So SQL is the language that you will mostly use for communicating with databases. It allows you to create, retrieve, update, and delete operations just as you could with, say, Python. So here's an example of how you create a table. So you'd say create table, and then you put in the name of your table. So it could be users, it could be tokens, it could be tickets, websites, I don't know. And for each table, you have to define your columns. So for column 1, it could be the ID, and it can have a data type like integer. And actually, I'll show you an example here. So here's a user table example. We create a user table. So create table user, and in parentheses, we say ID. ID is a pretty special column you probably want to have in most of your tables. And typically you'll want it to be an integer with a primary key field and auto incrementing. So primary keys, like it makes it the main key of your table. The key you're going to typically sort by, and the key that's going to be enforced to be unique. And auto increment just makes it so it automatically increments by 1 every time you add a new person. So that's something you will really want to remember. And for the rest of the fields, they're kind of whatever you want it to be. So name can be a text field. You can say it can't be empty. Same for the age. You can say a text field, you can say number. For email, you can specifically say, I want it to be 50 characters long, and so on. Yeah. Next, we're gonna go into, wait, do you have a question? Okay, sorry. So now you have a table, but it has no data in it. So the way to actually add new data is to say, okay, insert into my table, and then specify the columns you wanna insert data into. And then you wanna say values, and then the actual data values. So it would be like, okay, oh, One thing also is that you don't have to say the actual column names that you want to insert data into, because typically they don't change. So you can actually omit them and just say the values as long as you're using all those columns. But it's kind of a bad thing because it's hard to read. Imagine you just had insert into table users, insert into users, ID, like 1, Caduce, 25, actually 21. Why did I say 25? But you wouldn't know what those values meant without extra context, right? And also, if you change the order of the columns, you have to change the order of the data. So it's best to specify what you mean. Here is a concrete example. So insert into user, we want to insert data into the name field, the age field, and the email field. And the data we want to put in is John, 21 years old, and then his Cornell email. So you can see why you want to have the actual fields there. It makes it easy to understand what that data means that you're inserting if you're reading someone else's code. Next, we have selecting data. So you want to find specific data of some specific thing from your table. The way you do it is by saying select, and then you want to type in a list of the columns you want. So you might want to get the ID, the name, and the email of some person. And then you want to say from the table you want. So from users. And I'll just give you all the data from users, their ID, their name, their email, right? You can also say star to just generally say, give me all the fields from every user you find. So it's selecting all the columns. An example, oh, there's no example. But one more thing you can add onto it is the condition. So if you don't want to get all the data from all the users from the table, you can specify on a condition. So, do you have a question?
Yeah, sorry, for the insert table, does that replace the current table or does that?
It actually just appends a new row. So these tables stick around. So the condition tends to just be a Boolean. You can say like, we have an example on the next slide. Yeah. So I want to select all the users or all the rows. Actually, let me reset that. I want to select all the columns from user where the rows of that person is over 18. So I want to find all the people in my table that are over or equal to 18 years old. And I want to get their first name, their age, their email, because that's all of the fields based on the star. And a cool thing about these where conditions is that you can build onto them. You can just say and then say age is less than 25, or you also say or, you can also say not. It's just like a if statement in Python. Next up is updating data. So for updating, you say update and then table name. And then you want to set the specific column name, column values by using set and saying column 1 equals new value 1, column 2 equals new value 2, and so on. You don't have to say all the columns. You can just do the ones you want. So just a subset of columns is good enough. And then you also have to put in a condition. Otherwise, you're going to update everybody in the table. And that might not be what you want. It might be what you want. Depends on what you want. So say I want to update users and set their email to be johnsmith@gmail.com, where their ID is 1. If I didn't have the where clause, I'd set everyone's email to that. But I only want to set to that person's. So yeah. If I'm going too fast, I can slow down a little bit. Next up is deleting data. So you can just delete data from a table by saying delete, and then from, and the table name. And all you need to add is the conditions. So you don't delete everybody from the table. So example of that would be deleting from the users table where the ID is 1. And I'll delete John Smith from before and those. So yeah, those are the basic SQL commands. And now we're gonna go into a demo to actually show off how we'll do it in this course for now. I can click this on somehow.
So for this demo, we're going to be working with SQLite 3, which is a tool built on top of SQL. And it basically allows you to store a database in a file, which is really useful for like smaller projects. Oh, shoot, yeah. Yeah, that's good. That's good. All right. Yeah, so in real life, databases are stored in super large servers and use the internet, but here the databases are going to be stored in a local file. So that's why it's going to be better to use SQLite 3 locally on the computer. To install SQLite 3, the instructions are in the textbook under the chapter 2 section. And in today's demo, we're going to be creating a database showing the favorite ice cream flavors of the backend course staff. So first, we're going to start off with creating the table. So to get SQLite 3 running in the terminal, we just type in this command, SQLite 3. And this is going to allow the user to run and execute SQL commands within the terminal. So to create our table, we're going to type in the following command, create table user. And so what's really cool about SQLite 3 is that if you press enter, you can create like multi-line queries. So now we're gonna, oh yeah, so all queries are ended with a semicolon. So you can press enter as many times as you want. So yeah, and so our first kind of field in this table is going to be the ID. So we're going to write ID. Sure. And so our primary key, the primary key is basically like the unique identifier for the field. So we're going to want each entry to have like a unique identifier so that two people don't have the same ID. So yeah, and the auto increment, like Kadu said, basically means that whenever a new person is added into the database, you increase the ID by 1 so that 2 users don't have the same ID. And we separate this field with a comma, we hit enter. So the next field is going to be the name of the person. And so we're going to do name, and then text is going to be the type. Text is basically the string equivalent in SQLite 3. And then also we're gonna have the not null constraint over here. And what this basically means is that there has to be an entry within the name column, because you don't want an entry with a person that doesn't have a name, so you can't identify them. And again, we're gonna have a comma and then enter. And then so our next column is gonna be our favorite flavor. And again, this is gonna be a text not null. The reason why it's going to be not null is because this database is kind of designed around showing the favorite flavors of users. So if a user didn't have a favorite flavor, then there's really no point of the user being in there. So that's why you're going to want it as not null. And then we're going to have the favorite topping is going to be the last field. And this could be of a type char and 20. So this basically means that this entry, so char is basically, again, like a string, but in SQL. And the only constraint is that it has to be less than 20 characters. And then after that, we press enter. Since this is our last field, we don't need a comma. And then since this is the end of our query, we can just press parentheses and then semicolon. Then hopefully that should create something. So yeah, so then if we type this command here, dot tables, we see that we've created a user table within our database. So now we're going to insert some users into the database. So we're going to do this using the following command. So insert into our table name, which is user. And then we're going to name out the column. So like name, favorite, flavor, favorite, topping. And then values. And then so let's say I'm inserting myself into the database. My favorite flavor is cookie dough. And my favorite topping is strawberries. Yeah. And then again, we have a semicolon to end the query. And yeah, so then I've inserted this entry in here, and then we can use this command, select all from table user. And then so it shows the entry that I just created in here. The good thing about SQLite is that you can basically translate any query into English, which is kind of neat. So this star just means all. So you're saying select all from user, which is like pretty intuitive. So yeah, then we can repeat this process by entering more items into our table. So again, we can enter another person like Caduce. A quick trick for the terminal is that if you don't want to type in the command all over again, if it's really similar, you can just press the up arrow and down arrows, and this kind of like takes you to the previous commands that you've already like put into the terminal. So like going up or like more previous commands, going down or more recent commands. So I'm gonna insert someone else. So let's say use. Say it is Rocky Road and say his favorite topping is gummy bears. And this should work. And then if we go select all from user, we see that Caduceus entry is now in the database. And so let's add another entry. This time we're going to do something a little different. So let's say this is Mateo. And his favorite flavor is going to be vanilla. Oh, and then, oh, my bad. What I do? Yeah, I lost it. All right, gotta type this in again. So what we did here is we only had 2 fields for Mateo. And that's because when we first defined our table, our favorite topping field, there was no not null constraint. So this field is optional. So for entries, you don't have to include this field. So this is why we do select all from user. This works. We see that Mateo doesn't have an entry over here for his favorite topping. But if we tried to, if we tried to make an entry where someone doesn't have a favorite flavor, so let's say Joyce, delete this column over here. Should get an error that says the not null constraint failed for the favorite flavor, and that's because we didn't enter a favorite flavor. So now we can move on to some select statements. So, oh, question? Yeah.
So can you, for example, for, the second, any edits? We can see like, edit the responses, for example, change another,
Yeah, we'll get to that. Yeah.
Well, this is just like the small thing, but if you're creating a table, like how can you do it back?
I think, yeah, I don't know. I think if you do the up and down arrows, you're gonna get like different like terminal commands like pop up. So I think you just have to like press backwards like manually, like backwards arrow. It's pretty annoying, but yeah. It's good. All right. So yeah, now we're gonna move to some select statements. So like we saw, if we select all from user, we get these 3 entries. And so with select statements, you can also like put certain parameters within kind of like what you're searching for. So like instead of select all, we can select name from user. And so that's going to return all the names of the users that are in the database. So Tony, Caduce, and Mateo. We can also select multiple columns within this database. So like name and favorite flavor. And this is going to return the name of the user and their favorite flavors. But if you try and kind of reference a column that's not in here. So like favorite drink. I'm gonna get an error that says no such column, favorite drink. So let's say that my favorite topping just suddenly changed to blueberries and I want to update the table. So what I can do is, like in the examples, I can use the update keyword. So I can do update user, update table user, and then set the favorite topping to blueberries. And then on the where condition, so we know that the entry for my the ID for my entry is 1 over here. So we could say ID equals 1. And if we again go select all from user, we're going to see that my entry has updated to now my favorite topping are now blueberries. So let's say I become lactose intolerant for all of a sudden, and now I can't eat ice cream anymore. And so I don't have a favorite flavor anymore. So now I'm going to want to remove myself from the table. So we can remove my entry using the delete keyword. So we can do delete from table user where my ID is 1. So that worked. And then if we again do select all from user, we see that my entry is not here anymore. And then let's say that I convince everyone in the world that ice cream is bad for you and you shouldn't eat it and it makes you fat. And everyone doesn't want to eat ice cream anymore. So then I can say, if I want to drop the table, I can use the drop table command. So drop table user, and that drops the table. So now if I do dot tables, there's no tables. There's no user table. So yeah. Yeah, so that's it for the demo. And now we're gonna go to the Kahoot. Oh yeah, are there any questions? My bad. Yeah.
When we change blueberries,
Yeah.
can we say their name?
Yeah. The where condition is very flexible. You can reference any column and then yeah. I think I don't know it off the top of my head. I would just enter it manually. Okay, yeah. Oh. There's also a not keyword that you can possibly use. Yeah, like not equals, but yeah, I don't know. Yeah. Anyone else? All right. So we'll move on to the Kahoot.